Hello folks, Miss Roll here with your Ions and Isotopes notes. Our learning objective for these notes is that I understand ions and isotopes. These are something you maybe heard about in other classes, but are probably new terms to you. So we are gonna kind of learn what they are or add to what you already know. So first of all, can an atom be different? Right now we've taught you what the protons, neutrons, and electrons are for an atom that's neutral, that is not being different, but there are some things that can change about an atom. So first of all, protons never change. They're the one thing that is inside of our atom, protons, neutrons, or electrons, that will never change. If the protons was different, it was a different element, because that's literally what defines the element, right? Protons define the element. The neutrons and the electrons can change. Okay, so those two can change, and we call them different things. So in this case, when neutrons or electrons change, it stays the same element, but it's just slightly different. And we'll kind of go over what that looks like. We've got a picture down here if you want to look at that. That's an example. So first of all, isotopes. What are isotopes? These are when the neutrons are different. The Bohr model stays the same. So the Bohr model, if you learn to draw, it looks the same, except the neutrons, you just have a different number that you'd write in there. It's the same element. It has the same characteristics. It just has a different mass. And fun fact, it's actually why our masses, our atomic masses at the bottom of our square, are a decimal point, because it's an average of all of the isotopes of that element. Fun little fact for you. So what are ions? These are when the electrons are different. An ion is a charged atom. So electrons, we know, have that negative charge, right? Protons are positive charge. If we're changing the number of negative charges, it's going to give us a overall charge to the atom. Okay, so far, we've been dealing with only neutral atoms until now. Okay, I mentioned this in our last video that we were only going to deal with neutral atoms until a bit later. It's later, okay? To become charged, it either loses or gains an electron. Now, this little bit here that I'm about to say, and I'm kind of circling with my mouse, is probably the most important thing you can take from this video to remember. So when you lose an electron, it becomes positive, right? So if you think about this, if our lithium atom has 3 protons and 3 neutrons when it's protons and 3 electrons when it's neutral, it balances out, right? 3 positives, 3 negatives balances. If we suddenly lose one of those electrons, we have 3 positives and 2 negatives. Now we have an overall positive charge. And the opposite is also true. When you gain an electron, it becomes negatively charged. So if we went from 3 and 3 for protons and electrons to 3 and 4, now we have a negative charge because we have 4 negatives and only 3 positives. All right, so what are valence electrons? Valence electrons are electrons in the outside shell. So you've learned how to draw these Bohr models, and you fill in from the inside shell as far out as you go for the number of electrons you have. When we say valence electrons, we're just talking about those ones in the outside shell. It's an easy way for us to reference those. Now, atoms want to be happy. Okay, this is how I like to remember it. And for an atom, happy means a full shell on the outside. So whatever that outside shell is, it wants it to be full. That makes the atom happy. We'll talk more about what happy looks like for an atom when we talk a bit about reactivity and reactions. But just for now, know outside shell full means it's a happy atom. So atoms that don't have a full outside shell will either give up or take electrons to be happy. So in the picture there, we have a lithium ion, right, with 1 in the outside shell. Okay, we have 2 in the first shell, but then 1 in this outside one. Now we know this shell fits 8. So to get that whole shell to be full, it would have to gain 7 electrons, which is a lot more work than just giving up 1. So in this case, our lithium gives up the 1, and now it just has 2. That's the only shell, so its outside shell, the one outside one with electrons in it, is full. So a lithium is happy, okay? And so these are ions, kind of how ions are formed and why they're formed. All right, that is it for our ions and isotope notes. Remember to ask questions. That is the best way to learn, and I hope that you have a fabulous day.